Hi guys, today I'm going to go over questions 16 through 20 from the 2017 AMC8. Timestamps to each question will be provided in the description. Question 16 states, in the figure below, choose point D on BC so that ACD, or triangle ACD, and triangle ABD have equal perimeters. What is the area of triangle ABD? Okay, so let's draw that. Let's say this is about isosceles, so this is also 3. So this point would be labeled D. And for triangle ACD and ABD to have equal perimeters, let's say this is x and this is 5 minus x. 3 plus 3 plus x must equal 3 plus 4 plus 5 minus x. So that would be 2x equals 6, or x equals 3. So let's write that. 3 and 2. What is the area of triangle ABD? Okay, let's label the angles of this triangle. This is a 3, 4, 5 triangle, or at least triangle ABC is a 3, 4, 5 triangle. So angle A is a 90-degree angle. Angle B, let's label beta, and this is 90 minus beta. So what is the area of triangle ABD? Well, first of all, let's drop an altitude. An altitude. So right here, that's our altitude. So how do we find the length of this? Well, we can use similar triangles. Triangle ABC is similar to triangle, let's label this point Z, triangle ZBD. So 2 over 5 equals, let's label this y over 3. So that's 6 equals 5y, or 6 over 5 equals y. And the area of triangle ABD is 6 over 5 times 4 over 2, and that equals 12 over 5. So the area is D, 12 over 5. Question 17 states, starting with some gold coins and some empty treasure chests, I tried to put 9 gold coins in each treasure chest, but that left 2 treasure chests empty. So instead I put 6 gold coins in each one, but then I had 3 gold coins left over. How many gold coins did I have? Okay, so first of all, let's say G is the total number of gold coins. Oops. And let's say that T is the number of treasure chests. So we know that 9 gold coins in each treasure chest left 2 treasure chests empty. So gold coins, the total amount, equals 9 times the amount of treasure chests minus 2. And we also know that the gold coins equals 6 gold coins in each treasure chest, so that's 6t, but then you have 3 gold coins left over, so that will be plus 3. Now we can just set these equations equal and solve for t, and then we can plug t back into the equation to solve for g. Okay, so let's do that. 9 times t minus 3 equals 6t plus 3. 9t minus 27 equals 6t plus 3. 3t equals 30, so t equals 10. And if t equals 10 and you plug it back in here, then g equals 6 times 10 plus 3, and that equals 63. So you have 63 gold coins, and that would be D. Question 18 states, in the non-convex quadrilateral ABCD shown below, angle BCD is a right angle. So let's label that. AB equals 12, BC equals 4, CD equals 3, and AD equals 13. What is the area of quadrilateral ABCD? Okay, well, first of all, let's draw a little line here. We know that the area of quadrilateral ABCD is equal to the area of triangle ABD minus the area of triangle BCD. So let's find the area of triangle BCD first. First of all, we know that BD must equal 5 because this is a 3, 4, 5 right triangle. So the area of BCD equals 6 because it's 3 times 4 over 2. Second of all, let's go to ABD, triangle ABD. We know that triangle ABD has to be a right triangle because 5, 12, 13 perfectly make up the Pythagorean theorem, where 5 squared plus 12 squared equals 13 squared. It's a Pythagorean triple. So angle ABD is a right angle, and the area of triangle ABD is 30. So 30 minus 6 equals 24, and the area is B. Question 19 states, for any positive integer n, the notation m factorial denotes the product of the integers 1 through m. What is the largest integer n for which 5 to the power of n is a factor of the sum 98 factorial plus 99 factorial plus 100 factorial? Okay, first of all, let's take this sum and write it a little bit differently. Let's write it like this: 98 factorial, parentheses 1, because that's just 98 factorial, plus 99, because 99 factorial is 99 times 98 factorial, and 99 times 100, because 100 factorial is just 98 factorial times 99 times 100. So now that we have this, we can find how many 5s can fit or be a factor of each of these two factors. Let's do this first. Okay, so first of all, 1 plus 99 plus 9900 equals this. What am I forgetting? 10,000. So this would equal 10 to the power of 4. How many 5n's could be a factor of this? That would be 5/4 being the max. Second, we can do this, 98 factorial. First of all, let's count how many just plain 5s are in here. That would be 19 being the max. And then let's add the number of 5 squareds that are in this factorial. That would be 2. So that is, wait a second. No, this would be 3. So that is 22 5 to the power of n's that can fit in 98 factorial. So the largest integer, n for which 5 to the power of n is a factor of this sum, would be 22 5 times 5 to the 4th. That equals 5 to the 26th. That equals D. Question number 20. An integer between 1,000 and 9,999 inclusive is chosen at random. What is the probability that it is an odd integer whose digits are all distinct? Okay, let's write out the possible digits. That would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's think about the last digit first, this one. So for that digit, we have 1, 2, 3, 4, 5 choices. Because it cannot be even, that would make it an even integer. So 5. Then let's move on to the very first digit. For that, we would have 1 choice taken away because we used 1, and 0 taken away because the first digit cannot be 0. So that would be 1, 2, 3, 4, 5, 6, 7, 8 possible choices. Next, let's move on to this digit. For that digit, you would have, let's randomly just cross out 1 for convenience. 1, 2, 3, 4, 5, 6, 7, 8. 8 possibilities. And for the last one, we have 1, 2, 3, 4, 5, 6, 7 possibilities. So the total number of ways we can make an odd integer whose digits are all distinct is 8 times 8 times 7 times 5. Now let's find the total amount of integers you can make, or the total amount of integers between 9,999 and 1,000. So that would just be subtract and add 1 for the extra 1 you took away. So that would be 8999 plus 1. That equals 9,000 integers. You could also just multiply out 9 times 10 times 10 times 10 because you have 9 choices for the first digit, 10 choices for the second, 10 for the third, and 10 for the fourth. So our probability would be 8 times 8 times 7 times 5 over 9,000. And if you simplify that, you get 56 over 225, or B. Thank you so much for watching. Stay tuned and subscribe for the rest of the 2017 AMC 8.